Uh, Whoa! Now they can hear me in the other room too. And am I standing in a bad space, or the echo's not too bad? Okay, great. And in fact, so I know at least Jack and VJ were. Who remembers 2004 when we were in Siberia? I mean Wheaton, Illinois. Yeah, where we started, or Carol started, the Voice over IP conference. Which was about this size, but it grew over the years, and that's IPTCom today. So again, for the four of you who don't know this, I'll give you kind of my random walk how I ended up at the FCC. Back in 1991, I worked for this upstart company that was working on bringing down the price of phone calls. It was called MCI. And I went there because in those days, it cost a few dollars a minute to make a long-distance call, and we were bringing the United States closer together. We were dropping the cost of communications. So that was like one of my drivers, how to bring people together. And one way of doing it, make it less expensive. Again, I know a bunch of people remember this, or actually I should do it the other way. Who wants to say what Snowshore Networks was really about? So you guys remember Snowshore, and you're thinking media servers. But what it was really about, and two of the patents were about, was bringing the web model of application, telephone application development the web model of the application development to telephony apps. And the reason for that was, in order to build a telephony app, you needed to be an expert in Q931 or AIN or SS7. For the students, do you have any idea what I'm talking about? We succeeded, because you don't need to know that today. And in fact, the goal was then to make it such that a high school student who could build a web page could also build a telephony app. Who remembers Parlay? Yeah. The idea was, all right, well, you need to know all this esoteric stuff to build a telecommunication app. If you worked at Ericsson, you did it in this language called CHIL, which nobody really knew. And so the idea was, we'll take this AIN stuff that nobody really knows and understands, except for probably 3 people in this room. Wrap it in Java because, well, everyone knows Java. And so now you have a Java API onto something nobody understands. So that didn't work very well. But on my random walk, there was another company called BEA Systems, which today is part of Oracle. And BEA's claim to fame was, in a world where there's Apache and other open source web servers, people were paying us a lot of money for a paid high-performance web server. And so they took that, married it to SIP, and really started promoting this technology called ParlayX, which was, instead of just wrapping AIN in the web, we just took a web model of how to get at the telephone network, and that kind of became the killer app. But that's not the only thing that happened. A thing that I wasn't involved with, but will play into some of the FCC stories in a minute, is open source. There were things like Mobicent, Sun got in with some open source telephony platforms. But the one that everyone knew about then, and the one that everyone knows about today, is Asterix. I'll get back to Asterix in a minute, because that's played into an FCC action we just did a month ago. At the same time we're creating these applications, kind of that dream of MCI, of reducing the cost of communications, got accelerated with interconnected VoIP providers, who really have kind of driven the cost of placing a call to near zero. So now anyone can contact anyone. We're efficiently connecting the world, and that dream of mine has turned into a nightmare, because the bad guys are doing it. The bad guys are very easily creating communications applications. The bad guys are connecting those applications to everyone all around the world. And could you do me a quick, is it possible to like close the curtain? Thanks. So I see you guys are like in the, I really should be asking you more questions because now I'll get the honest answers with the light blinding in your eyes. So I see people kind of moving around trying to get into the shade. So, you know, I could say that I'm, is that better for you all? I'm doing my penance at the FCC since I kind of helped create this problem. And so I would also offer that if you're feeling a little guilty about it or you just want to actually have a lot of fun too, the FCC does have advisory committees. We do have, all of our rulemakings are public. We encourage you to comment. Please comment. Thank you. Thanks a lot. Is that good for, better for you all? Oh God, yeah, right. At the FCC, our number one consumer protection issue is robocalls. We're all personally impacted, whether, probably in this crowd, we're just being annoyed, but you probably have a story of a friend, or more likely a friend of your parents or something like that, who've actually been scammed. You know, they've actually had real impact due to robocalls. In public safety, I was visiting a public safety access point, a 911 call center, and asked them if, in fact, I actually asked them, I was more interested in caller ID spoofing, but they went straight to how a legitimate carpet cleaning company basically screwed up and tied up all of their lines. You know, a robocall campaign, basically doing a denial of service on a PSAP. Luckily, it was their administrative lines that got all bollocksed up, but still, that impacted operations. It could have been worse. The chairman gets robocalls. Some of them are probably nasty people targeting the chairman, but most people are just randomly dialing. I get robocalls on my FCC desk phone and my FCC-issued mobile phone. Half the time I want to say, do you know who you're calling? Half the time, actually, a third of the time I do actually answer if I'm bored, get some entertainment. But clearly a really big problem. We're getting about 200,000 complaints a year. Now, you might have heard of numbers of in the millions. Part of that is the FCC's advertising budget isn't as large as the FTC's advertising budget. The Federal Trade Commission's robocall complaint website does get about 2 million hits a year. But if you do go to the one thing I could have put up on the screen, https consumercomplaints.fcc.gov. You can go and complain and give all the information. We have a nice hosted communications product, so I get my voicemail as an email. I can attach it, so you can, if you have the recording, you can attach it to your complaint. It does help because it does help us figure out where to focus on, particularly enforcement actions. The title of the talk is the FCC's Comprehensive Approach to Robocalling. And the blurb was talking about, IETF protocols and how, we're promoting the use of that. But a thing to really understand is this is not a technology problem. The technology problem is we've created technologies to make it easier for criminals to be criminals. But criminals are criminals, and we need to treat the criminals as criminals. So it's not just a technology issue, but also issues of enforcement action. And I'm getting a neighborhood dialed robocall on my FCC phone. I couldn't have. Yeah, I just had a feeling this would happen, and I was thinking of making it happen. I didn't need to make it happen. It statistically would work with 2 phones. In half an hour, someone's going to call me. That's not supposed to.
Happened twice to Commissioner Rosenworcel during the last open
During the open meeting, that's right. So things that we're doing besides technology, before I get into the technology, we've issued the largest fine ever in the FCC's history. So not just the largest robocalling fine, but the largest fine, $120 million for a fellow who placed 96 million calls in about a 3-month period. And this is, again, part of the story. This individual was not a technological mastermind. Part of how he was caught was he posted on a message board basically saying, I've got this asterisk thing and I need someone to help me basically turn it into a robocalling platform. So on the one hand, we get this stuff, but it's also showing the tools that people are using out there. And along with that, I mean, this did help the number, but we've issued over $200 million in fines this year alone, which is unprecedented. There are a couple here and there for 10,000, 18,000, 67,000 in prior commissions. I think now we're taking a much stronger stance on the problem. So how do we find them? Let's say you're a carrier, and is there anybody from a carrier here? No, but most of us sell to carriers. But from the carrier's perspective, unless they're a wireless carrier, where I'll get a little bit cynical, but only a little bit cynical, you're as much a victim as your customers are victims, because you're bothering your customer. You're probably not going to get paid for that call. And your customer is going to call you, even though the call originated in the Philippines through some no-name interconnected VoIP, DID termination facility. So it's a problem for you as the carrier. So carriers do what they do. They got together. U.S. Telecom has a robocall. They call it the Robocall Traceback Work Group. And it's, it was like 24 carriers, but they kept merging. I think they're down to 22 carriers, but it's still all the same carriers. And they'll basically say, we're seeing a lot of calls with these characteristics. And someone else will say, yeah, we're seeing that too. And they say, okay, let's go figure out where this is coming from. And then they exchange Excel spreadsheets. So it's a very labor-intensive process, which means they only do it for like the worst of the worst. And again, it helps us because we can also, send a subpoena to try to get this kind of information. You might be shocked to hear that these robocallers are changing their caller ID. So you can't just look at the caller ID to find out where it's coming from, which is part of what makes this manual process. And obviously, and most of us know what the answer is for that from a technology perspective, but one of the points I want to point out is there are over 3,000 carriers in the United States. Most of them actually really don't need to be participating in this robocall work group. They have, on average, 1,200 subscribers, and they literally know their subscribers. But there are some carriers who appear to maybe be in the business of facilitating illegal robocalls. And that's something that we'll probably be looking into. Either encouraging carriers that are not participating in Traceback to participate, and encouraging dealing with criminals the way we deal with criminals. And in fact, the people lying about caller ID, I think is there anyone here who doesn't know what stir and shaken is? Oh, cool. All right, I guess I will. I've got time. I'm till 9:30, Carol? Okay, great. Let's see. Jack, is your name on any of it? Or Alan?
No, we just
You just do it. Yeah.
It was by far one of the most popular topics.
Yeah.
features in our products go through my organization. That doesn't mean I'm an inventor.
Okay. So STIR is an IETF standard. It's published as an RFC now. It's actually a suite of RFCs like most things in the IETF. And what STIR does is it puts a cryptographic signature basically onto, from, call ID, date, and some other stuff. Most people, when they think of STIR, rightly think of it as, oh, we are going to protect the integrity of, most particularly, from. That you say you're from, let's see, who just spammed me? 202-486-9212. That's a neighborhood dialing thing, so now you already know the NPA Annex X on my phone. By cryptographically signing it, no one's going to change it in flight. Well, guess what? Nobody has changed it in flight. What's more of interest to us is shaken, which is the framework for doing that actual signing. That work is not an IETF work. Why is it not IETF work? Because it's all about carriers in North America. So for example, in the IETF, we say, sign the signaling using PKI. And if you look at the web, who is authorized to issue certificates? 200 of your closest friends and relations, including the Turkish telephone company, 3 telephone companies in China, the Chinese government, the US government. DOD's got a bunch of certificates in the store. And as we can see with like interconnected VoIP, there are a lot of great people who've really helped make telephony affordable, but there are some that are facilitating robocalls. And you could imagine if you have your pick of 200 certificate authorities, somebody would probably see how far they could stretch the law. Actually, this is an important thing. So I do advise the entire commission. And like you're talking about one of the commissioners, they have different points of view. But as a whole, they have a point of view. One thing is you keep hearing me talk about illegal robocalls. And that's an important distinction because we basically, actually, I wouldn't say we only dislike illegal robocalls. We also believe in consumer choice. So a lot of the policy work at the FCC has been around, you can imagine, some of the legal, let's not call them robocallers, legal automated dialing users want us to say the user has to get the call, and in fact in their world, and the user has to answer. To which we say, look, if it's a legal call, we won't let any carrier block it, but if the user gets an app or the user decides not to answer it, we are not going to get in the way of that. So let me preface it. All this discussion is about illegal robocalls, and the statute is actually pretty specific about what constitutes illegal. You might have seen there was a circuit court case that kind of blew up a prior ruling on what is an auto dialer. And a lot of the comments were, oh my goodness, you can't tighten the definition of auto dialer because then the bad guys will get around that definition and will be bombarded by robocalls. But the language of a law is very important. The TCPA, the Telephone Consumer Protection Act, talks about, a call's illegal if it's done with an automated dialer or basically as IVR. And most robocalls are IVR. So, the last commission went over the top and basically said, this is a robocall platform, which is, well, actually, I wouldn't say it's ridiculous. It's actually reasonable if a bad guy uses it to automatically dial bunches of people that are on the do not call list and they have no prior business relationship with. However, we can still capture them in their bad ways with saying, well, no, it does have the characteristics of a dialer, not possible. They're using it as an auto dialer. And oh, by the way, they're starting off with a pre-recorded message and they're scamming people and they don't have the pre-existing condition. So Shaken basically defines the PKI. It says who is allowed to issue the certificate that signs that signaling. In the IETF, we're always about end-to-end, which is, again, why Shaken was not done in the IETF, because in Shaken, it is the service provider who signs the signaling, not the end user. Part of that is because then, like government agencies who these people get licenses from to operate might be able to say, don't lie, and bad things will happen if you lie. So it's a slightly complex thing because, again, it's law policy, and most of us, okay, show of hands here, who doesn't know Rich Shockey? I expect you don't know who Rich Shockey is, but you don't know Rich? Yeah. He's chairman of the SIP Forum, and Shockey's law is money's the answer, what's the question? So this is an issue where there's money is the answer, so why haven't we done Shaken yet? So we need to figure out who's allowed to sign, basically issue signing certificates to carriers, so that we call that a certificate authority. But the problem there is we need to figure out, so who's a carrier? Of these 3,000 carriers, who's really a carrier, and who's Joe's robocalling an illegal fraud campaign company. So that's a policy authority. And of course, in Washington, you then need somebody to watch over all that. So that's a governance authority. A FCC advisory committee came up with this model, and they're executing on it. And I would expect that we'd see a lot of deployment next year. And with that, so not only are we signing basically the caller ID, that's stirred and shaken, but we know who signed it, which is really important because remember I talked about traceback. Well, now we know who signed that call when it got into the network. A lot of the discussion of shaken and stir over the last 5 years was, oh, well, if it's signed, then we can trust it. If it's not signed, we can drop it. And a lot of us in these rooms were trying to tell the policymakers, no, it's not quite like that. And it's not quite like that for at least two reasons. One is, whereas I would expect all of the major carriers, or most of the major carriers that certainly have VoIP capability, will be signing their signaling into next year. A lot of carriers, especially smaller carriers, won't. So just because something that's not signed doesn't mean it's bad. Yeah.
So what if I have a signed robocall?
Yeah, so the nice thing is traceback. Because, and actually there were mostly IETF people out of Oxford, did a study on cybersecurity in the UK. And one of their results was $1 of enforcement, well, it was £1. 1 pound of enforcement was worth 100 pounds of firewalls and intrusion detection systems and network operating centers. So being able to find and arrest and fine and tar and feather and publicly flog robocallers, that is what I believe would make a difference. I'm not speaking for the commission on that, especially the tar and feather part. Yeah.
Eric, you bring up an interesting point. So I think it's great that we see these massive fines, and I think you said $120 million. If I was a robocaller and I received a $120 million fine, you get $39.48 and have a nice day. So while it sounds nice, is it really effective?
Well, part of it is we are a creation of Congress. The FCC can literally only do what Congress tells us. And one of the things is Congress tells us we can levy fines and civil forfeitures, but we can't put people in jail. The FBI, state attorney generals, local district attorneys, they can. And I think, and we're getting more and more, because this used to be a U.S. problem. It's now becoming an India problem, which is kind of ironic. It's kind of like cybersecurity in China. There is a heck of a lot of Chinese internet-based fraud against Chinese. And yet we also talk about Chinese internet-based fraud here. So we have strange bedfellows at the government level wanting to cooperate. Because another issue is a lot of these entities are not U.S. people by the legal definition of person. But I think we're going to see more and more cooperation. Because I think that's it, is, yeah, like this particular individual basically said, you can't fine me $120 million because I don't got it. Yeah, but it also hopefully is sending a message. And it's a lot better than saying, $18,000 and see me in the morning, show up someplace else. So is stir and shaken. Just because it's signed doesn't mean it's good. Just because it's not signed means it's not. We did a report and order that allows carriers to block calls that they basically know are bad. And they know it's bad because it has an area code that doesn't exist, or it's from an unallocated number, or it's from a inbound only call center number like the IRS. Frankly, at the time, I said this will reduce robocalls by 10% for 2 weeks because those calls were only 10% of calls, and the robocallers would learn to change their caller ID. And they have. We now see a big influx of neighborhood dialing. That's where you see the same NPA, NXX. Great for me because I have my cell phone from 2006. I know nobody who has that NPA, NXX. It's an automatic thing. Thank you for giving me extra time. I appreciate that. But what that did is it set the precedent. We now allow carriers to block calls, as long as it's an illegal call. The other thing I want to just briefly touch on, so I've got my FCC-issued mobile phone. Somebody had it before me. That somebody owed money on a loan. So I was getting calls to service the loan. Now, this was a person who had a business relationship and had said it was okay for them to be called, blah, 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 but I'm the wrong person. Again, this is a thing where we're kind of having to fix. The last commission basically said that they got one shot to get it right, and if they don't fix it, there's the company's subject to civil forfeiture. I do what most people do, which is I just let it go to voicemail, which actually means they've blown their one chance. And some, pick your adjective, some lawyers got involved. And started hitting probably legitimate callers for very outsized fines. So one thing we're working on right now, which we'd love your comments on, is a reassigned number database that basically you say, this is my customer, this is when they gave me permission. Has the number changed since they gave me permission? Oh, it has? All right, we won't call them. Or no, it hasn't. It's kind of a safe harbor. And we learned from the do not call database, which has become the whom to call database. This one will be structured in such a way you can't pull it all out. And with that, I would love to hand this over to the next speaker, and I'll be here all day if you have any further questions.
I think this is a topic that is probably best presented in a panel so you can ask questions. I will allow one question because we are a little bit over time. If anybody has a burning question to ask Eric, either on his personal desk or on FCC's behalf, please.
Yeah, so who's stepping
I actually don't know. The report that we got from the North American Numbering Council, which is FCC advisory committee made up of industry and consumer groups and Henning, academia. They did stand up the GA, and that's my understanding going on. I don't know who they are contracting with or planning on contracting with for the CA. That's not going to be the FCC. Okay.
One thing also I'd like to understand is that if you have a certificate authority, then you're actually giving an authority for a bunch of numbers, either an entire NP and XX or the NPA itself, right, as opposed to, so same analogous to domain names?
Well, so this is actually where, and then we hack the IETF model, because in STIR, you're supposed to have a certificate that covers the number that you're giving the attestation for. In reality, all we care about is who signed it. So, and there are cases, so there are a lot of large enterprises that multi-home. I get my numbers from carrier V and I place my calls on carrier L. They're not carrier L's numbers, but it's a legitimate call, and we want that to still happen.
Right. So Eric will be around here if you have any other questions. But in the meantime, I think, Eric, thanks a lot.
Thank you. Thank you all for your participation. No. Sorry to go over. I didn't expect to do that. I didn't expect to.
Check. Okay.
Good.
Yeah, I think it's working. Okay. So, hello everybody. Thank you for coming. This is my first time presenting in the RTC conference, so I think I need to allow me to present myself. My name is Jorge. I'm a PhD student at the University of Strasbourg, and I'm also working as a senior software engineer at Atlassian in Emil Evolf's team. Some of you may have, well, for sure, will have heard his name. I'm mostly working on the Jitsi Video Bridge and Jitsi Meet. Those are in the congestion control and adaptivity features of the Jitsi Video Bridge. Please do not use this web address. I was hoping I could share that with you, but it's not accessible through the Wi-Fi here, so don't do that. Yeah, let's get started. Before we get started, I would like to present, to say a couple of words about Jitsi Meet, our open source stack, what we run Meet Jitsi on. I would like to share some information about Meet Jitsi, which is a service that uses the open source stack to provide video conferencing platform, and some metrics for our Meet Jitsi service. So we're going to talk about WebRTC, where we are obsessed with quality, so we are going to see what we can do to improve the quality of service and the quality that we are providing to our users. Specifically, we're going to talk about dynamically switching between one-to-one video conferencing and group call mode, and what happens if we don't, and why it's important to do it. So about the Jitsi Meet stack, we have client-side applications, 2 of them. One that runs on the browser, and it uses the WebRTC JavaScript APIs that Bernarda Boba has presented yesterday during the WebRTC tutorial. And we also have another client that runs on the mobile, and it's built on React Native. It uses React Native WebRTC. On the server side, we have the main components that we have. We have multiple components, but the main ones are GCOFO, which is our signaling server, and GC Video Bridge, which is our SFU, the media server. SFU stands for Selective Forwarding Unit. We also call it the bridge. I'm going to be using all these terms to refer to the GC Video Bridge, our SFU, throughout this presentation. For the signaling path, we are using XMPP, provided by Prosody, which is an XMPP server written in Lua. And for the media path, we use UDP, DDLS, and SRTP as, and God forbid, TCP, as is mandated by the WebRTC standard. So this is what it looks like. Here you can see, this is a screenshot from our daily stand-ups. You can see Yana. She's on stage, and she's being received by the specific endpoint at 720p at 30 FIPS resolution. So it's the highest resolution that we can achieve right now. And on the horizontal thumbnails bar, you can see some of our colleagues. You can see Pavel. Well, first you can see a participant that doesn't share his video, then Pavel, Boris, Christo, some of our, and those participants are streamed in 180p resolution and 7.5 FIPS. So their reduced, their resolution is reduced to fit the specific thumbnails. We have multiple layouts. GTMeet supports multiple layouts, so you can have the horizontal, the thumbnails bar at the bottom, the horizontal thumbnails bar at the bottom. You can have it on the side in vertical positioning. And we recently have released a Brady Bunch style layout that presents you all the participants on your screen and take approximately equal size. We have a lot of other features that are not relevant for this measurement, for this presentation. We have video quality sliders, audio-only mode, speaker stats, transcriptions, recordings to Dropbox. We have a bunch of stuff that we are not really going to talk about, but you're free to go on our website and just, or maybe even use our service and explore what we have. So this is on the, so about the other main component that we are using is the GC Video Bridge, our Selective Forwarding Unit, or SFU. It has, it implements conferencing features such as simulcast and last N. For those of you that are not familiar with these terms, most of you should be, but just as a reminder, simulcast is when an endpoint encodes and sends multiple versions of the video stream that it's sending, so that the bridge is able to forward the appropriate stream to the appropriate receiver. For example, Yana, in the previous slide that was on stage, we want to forward the high quality stream, 720p at 30 FIPS, and for all the other participants, we want to forward 180p at 7.5 FIPS. We also support last N, which is the bridge selects the last N. N is a number like 2, 3, 4, 5, or 10, or this is adjustable. The last N active speakers. And this is again to save bandwidth and optimize the user experience. The user experience for the participants. We also have the protocol that we're using to communicate with the GC Video Bridge is XMPP. We also have a REST API, so you're not bound to use XMPP if you don't like it, or if you don't want it, or if you can't integrate it. We have callstats integration, callstats.io, and the same applies for the GTMeet client that we showed in the previous slide. So a few words about the video conferencing platform and system that we used for this, that we performed this measurement study on. It's the MeetGTC Cloud. This is not open source. I forgot to mention the previous projects are all open source. That's why you have the banner fork me on GitHub. The thing that is not open source is it's our cloud infrastructure and how we scale to provide a video conferencing experience. So we do that. We scale horizontally using shards. Every shard has all the components necessary to serve several conferences. So it has all the signaling components, Prosody and GCOFO. It has an auto-scaling group of SFUs. So just in case there's a lot of traffic driven to a specific shard, we increase the number of SFUs that live in that specific shard. So we deploy on multiple regions. So we have a geographically distributed cloud. We deploy on North Virginia, Oregon, Ireland, Australia. Those are our main regions. And we have multiple shards per region and an auto-scaling group of turn servers in order to support one-to-one call modes in case the direct connection fails to establish. All this is behind an HA proxy cluster, which is geographically distributed, and its purpose is to drive participants of specific rooms to specific shards. So a conference room lives in a specific shard, and all the participants are driven to that specific shard. And the choice of where a room lives, whether it's in North Virginia or Oregon, it's determined by the first participant. So if the first participant is close to North Virginia, he's routed there. We have C4X larges for our SFUs on the turn servers. They have high network performance, and they have plenty of CPU and RAM. So a few words about our service. This past month, we crossed the 90,000 conferences. This makes for about 3,000 conferences per day. We have a little more traffic during the week. We have a little less traffic during the weekdays, the weekend. The average conference duration is 38 minutes. Average participant count, about a little bit more than 3 participants. So we have plenty of 3-way calls. All this sums up to 3.5 conferencing minutes, or a little bit more than 7 million participant minutes. The average RTT is a little bit below 300 milliseconds, and the average upload is around 1.1 megabit, and the average download bitrate is 500 kilobits. Now, this is highly asymmetric, and we can explain this again. This is explained by the use of simulcast. So if a participant is streaming 1.1 megabits per second and simulcast is activated, you're going to have, at that specific threshold, 1.1 megabits, you're going to have 2 streams that are being streamed, one 180p stream and one 360p stream. So the participants, the receivers, are not going to get all of that. They're going to get just either the 180p stream or the 360p stream. So typically they receive less than that 1.1 megabit per second. So this explains the asymmetry in the average upload and download bitrate. We're going to break down all this information later in the results section. So this is just an overview of our service. So peer-to-peer for one-to-one. Here we're going to see why this is important, what this does. We're going to talk briefly about some related concepts such as congestion control. Hopefully, we're going to be able to motivate this work and why it's important to have it. We're going to precisely define it. Group call versus one-to-one call mode, what features get activated, and why it's important to deactivate conferencing features in one-to-one call mode. We're going to see other implementations. Big players have been implementing this. We're going to see who does it and who might do it in the future. And we're going to overview the Jitsi Meet implementation, what we have implemented in our projects. So congestion control, now I'm going to limit myself in just one slide. This is a huge topic. I'm not going to talk about, it's 40 years of research and experience. We're going to limit ourselves, myself, in what's related and relevant for this, for the measurement study. Our service uses the Google Congestion Control, which is baked into the WebRTC engine. This is a feedback control algorithm. It takes information. The input is the packet loss and the packet delay variation. There are several proposals in the IETF RMCAT working group for other algorithms to either replace or work along the Google Congestion Control algorithm. The basic idea is, the reaction of the GCC, which stands for Google Congestion Control, is So it has an additive multiplicative, additive increase, multiplicative decrease reaction to loss, and so this is how it reacts to loss and how it reacts to packet delay variation. Basically, if you have a positive packet delay variation, that means that you're filling up the network queue, so you're causing congestion and you need to back up. And if you have negative packet delay variation, the network queues are being emptied, so you can ramp back up. It's not as simple as that, because you may decide to use some part of bits for forward error protection, and also you want to avoid situations where you have a stale queue, and basically the packet delay variation is 0 and you don't know what's going on. Is it because the queue is completely full, or is it because you're underusing the queue? So it's a complicated algorithm, very interesting to read about. The algorithm is implemented both in the browser and the SFU. So we have our own Java implementation in the SFU, and this may, so it's not necessarily exactly the same that runs on the browser. So we have seen, I didn't explain the picture that we have here. So basically the sender is sending, let's say 2.5 megabits per second. The receiver is recording packet arrival times and packet loss, and it sends it back to the sender. This is through standard RTCP mechanism and packets that are being exchanged on the network. Through the packet arrival times, the sender is able to deduce the packet delay variation, and through the mechanism that I just described, it adjusts the target bitrate to match the bandwidth estimation that is produced by the algorithm. So this is working nicely in one-on-one calls where the sender can shape its bitrate and adjust its target bitrate to match the bandwidth estimation. However, in a group call, the SFU, well, we're using an SFU, so we're not doing any transcoding. We cannot, and we do not want to transcode the stream in order to match the bandwidth estimation, so we need to employ other techniques in order to adjust the egress bitrate of the SFU. So we have features such as simulcast that I described a couple of slides before. So the sender is encoding and sending multiple versions of the same video stream, low quality versions and high quality versions of the video stream that it's sending. This is costly and wasteful if you're not in a group call, because it requires more CPU and more bandwidth on the sender. So for example, this is sort of hard-coded right now in the WebRTC engine, and it's not configurable, but right now what happens is if you enable simulcast, you have 3.2 megabits per second target bitrate if everything on the network is smooth. If you enable simulcast, and if you don't enable simulcast, the maximum bitrate that the sender is achieving is 2.5 megabits per second. So we have 700 kilobits that are wasted if you enable simulcast in the one-to-one case scenario. So it's important. So if a video conferencing provider wants to be optimal in terms of bandwidth usage and user experience, it needs to be able to distinguish between these two cases and dynamically and transparently switch between these two cases throughout the life of the conference as participants join and leave the conference. So other implementations. First, it was announced by Google. Google Hangouts has this functionality. It announced it in February 2016. We implemented that. We actually released it. We released it on July 2017, so a little bit more than a year ago. Slack Video announced it. Well, actually, they mentioned it during ComCon in London a few months ago. We don't really know whether they were using that even before that. We don't know whether Facebook is doing something like that, Skype and Apple FaceTime now with their group calling functionality. But given that the impact and the infrastructure pressure reduction is so significant, we believe that at some point they will have to, if they don't already do it, they will have to actually take into account this dynamic switching and implement some version of it. So this is our implementation, how it works. In this diagram, we can see the SFU and two participants. The participants join a call always in group call mode, because this is faster to be established and it's more reliable to be established. So they always enter in group call mode. And if at any time during the call the participant number drops to 2, we enter the one-to-one mode, where a new peer connection is established, the WebRTC peer connection is established, and once that succeeds, once a connection is established and we have media flowing, we update the UI to move the audio and video tracks to the new peer-to-peer peer connection. If the participants increase and we go to 3, 4, or more participants, we fall back to the group call mode. We tear down the one-to-one mode connection, and we fall back to the group mode connection. And all the features, simulcast, last end, are being maintained and resumed. So results. So we compare measurements from 2 periods, the pre and post. Peer-to-peer for one-to-one. This is when we actually, before we activate, after we activate this extension, we are gathering stats on the client side using WebRTC Statistics API. We push these statistics to Splunk, and from there we export it and treat it and process it. For the server side, we have Datadog monitoring. This is a server-side resource utilization monitoring service. So we have got, for the infrastructure, we have gathered data about how much the transferred data, the amount of transferred data, and the SFU I/O stats like memory, CPU, system load, and things like that. And on the client, we have, for the quality of service, we have RTT, call establishment time, and download and upload throughput. So we're going to see the results now. Before we activate the extension, we gather data for 2 weeks. This is for a little bit more than 23,000 conferences, which amounts to a little bit less than 700,000 minutes. And 2 weeks, and we compare it to the period 2 weeks after we enabled the extension, and so we have almost the same amount of conferences. Less than very small change there, and the same amount of conferencing minutes. So we have 78%, almost 78% of the calls of the conferencing time is spent in one-to-one calls, and the rest is 3-way or more. So it's a very important use case. So the transfer data. So in this graph, you can see the blue graphs represent the pre-activation period, and the green graphs, the post-activation period. We can see that we have reduced our downstream, like the data that reaches the SFU, by almost 50%. The data that go out of our infrastructure have been reduced by 55%, and the total amount of transfer data has been reduced by 52%. So this is a significant reduction in the total costs. So about the SFU I/O, we have the pressure in our infrastructure has been greatly reduced as well. The memory we now use 35% less memory, 32% less CPU, and the system load across all of our bridges has dropped by 46%. So it's a significant reduction. Now about the round trip time, here we see, in this graph, we see the cumulative distribution of the RTT for direct connect, for calls that are directly connected through peer-to-peer, and relayed calls either through Turn or our SFU. So the blue line is the cumulative distribution of RTTs for direct connect calls, and the green line is for the relayed calls, and the vertical dashed lines represent the averages. So we can see that we have made the RTT smaller by allowing direct connections to be established. We're going to see exactly by how much. So we didn't have enough data for all of the regions that we deploy our infrastructure. So we have omitted Oregon and Australia. So we have focused on North Virginia and Ireland. So direct connect calls in North Virginia are 22% shorter RTT, and in Ireland they have 30% shorter RTT. And we have also observed a difference depending on the region. So server relayed calls have 60% shorter RTT in Ireland than in North Virginia, and direct connect calls have 24% shorter RTT in Ireland than North Virginia. So upload bitrate, and so this is the cumulative distribution of the upload bitrates achieved by the clients. We have three categories there. We have the direct connect calls, which is the blue cumulative distribution. We have SFU relayed calls, which is the green cumulative distribution, and turn relayed calls, which is the red cumulative distribution. All of them, there are multiple observations that we can do. All of them achieve about the same averages. They're about 1.1 megabit per second. The turn relayed and the direct connect cumulative distributions exhibit similar behavior, very different behavior for the SFU relayed calls, and this is due to the congestion control and the simulcast, and the fact that we activate simulcast. Again, the same. We can see the same here. We have the same picture here, but this is for the download bitrate. Very similar behavior for the direct connect calls and the turn relayed calls. Much lower performance on the SFU relayed calls because, as we mentioned earlier, if a participant is streaming 1.1 megabit per second, the receiver is not going to get 1.1 megabit. It's going to get much less, depending on the layout. So this is how this lower performance can be explained. So here, yes, 4 minutes. Yeah, thank you. I'm almost done. So this is a summary of all this. What's important to keep in mind here is that if you activate SFU conferencing features in one-on-one calls, you drop the call efficiency by a lot. So 52% efficiency in North Virginia and 6% efficiency in Ireland. So what this means is that clients are uploading, but receivers are not getting everything that's uploaded because of simulcast, RTCP termination, which is how we inject our congestion control into the loop. So it's really important not to enable conferencing features in one-on-one calls. So the conclusion, we have, by introducing this dynamic switching mode, we have reduced our bandwidth usage by 52%. The infrastructure pressure has been reduced by 35 to 40%, so less memory, less CPU, less load. We improved the RTT by 20 to 30%, depending on the region. The throughput has remained more or less the same, so this hasn't changed much. Yeah, the group calling features reduce one-on-one call throughput efficiency by a lot, so the efficiency is pretty low if you have conferencing features. So that's my presentation. Thank you very much for being here. Let me know if you have any questions. Thank you.